Okay, so in this video I want to discuss a proof of the quotient rule. So let's go through the proof here. So let's suppose we have Q, which is f of x over g of x, and we want to find a formula for q prime of x in terms of f of x and g of x. That's the goal. We know what the formula is, but we want to find it from first principles and thus prove that formula. All right, so let's just write out the definition of the derivative and apply it to this q of x. So the definition of the derivative is it's x plus h put into the function, x put into the function, and then the difference of those two quantities divided by h, and then we take the limit of that as h goes to 0. We know q is f over g, so let's put that in. So this is going to be f of x plus h over g of x plus h minus f of x over g of x all over h. All right, so I want to combine those fractions in the numerator. And the way that I'm going to do that is I'm going to create a common denominator. So I'm going to multiply the first fraction's numerator by g of x, and the second fraction's numerator by g of x plus h, and then the denominators will match. There'll be this g of x plus h times g of x. I'm also going to take this dividing by h and rewrite it as multiplying by 1 over h. So dividing by a number is the same as multiplying by 1 over that number. Okay, let me move this over so it looks a little nicer. There we go. Now we can combine the numerators. So we'll get f of x plus h times g of x minus f of x times g of x plus h all over g of x plus h times g of x, and we have this 1 over h. All right, now I'm going to do something that seems a little strange, may seem a little strange at first. I'm going to add and subtract something to the numerator. So I'm going to add and subtract f of x times g of x, like so. And because the adding and subtracting, they would undo each other, I'm not actually changing the numerator. I'm just changing its form. It's not turning into something new mathematically. It just looks different. Okay. I'm also going to take this 1 over h and apply it to the numerator. So let me write this as the numerator times 1 over h, and then all divided by g of x plus h times g of x. Okay. So let's keep going. Now what I'm going to do is I'm going to factor g of x out of the first two terms in the numerator. So I'll get f of x plus h minus f of x. And then I'm going to factor f of x out of the two terms in the at the end there. So I'll get f of x times g of x minus g of x plus h. And then I'm going to distribute this 1 over h to both these two terms, these two factored pairs. And I'm going to divide the whole thing by g of x plus h times g of x. Okay, so I'm just distributing this 1 over h to the two terms that I now have. All right, so now I'm going to rewrite the numerator slightly as g of x times f of x plus h minus f of x all over h. And if you stare at this second term, you can see that it's almost the derivative of g. We have this g of x plus h and g of x, but it's swapped. So what I'm going to do is I'm going to introduce a negative sign, And that will reverse the order of those two g of x terms. Okay, and then we'll divide the whole thing by g of x plus h times g of x. All right, so now we're pretty much done. We're going to apply limit laws to all of these terms. So the limit of a fraction, the limit of a quotient is a quotient of the limits, and then a limit of a product is a product of limits. So I can write this as limit as h goes to 0 of g of x times limit as h goes to 0 of f of x plus h minus f of x over h minus limit as h goes to 0 of f of x times limit as h goes to 0 of this g of x plus h minus g of x all over h. And then that's going to be over limit as h goes to 0 g of x plus h and limit as h goes to 0 of g of x. All right, and the limit of g of x as h goes to 0 is just g of x. The limit of this difference quotient is the derivative of f. The limit of f of x is just f of x. The limit of this difference quotient with g is going to be g prime of x. The limit as h goes to 0 of g of x plus h is g of x, and that's because g of x is continuous. And it's continuous because we're assuming that g of x is differentiable, and differentiable implies continuity. And then the limit as h goes to 0 of g of x is g of x. And so we have the familiar quotient rule, low d high minus high d low all over low squared. And that concludes our proof. I hope you found this video useful.